the piece that's putting pressure on the diaphragm isn't moving.
No, but it has, because it's a bearing, there's part of it's moving.
Welcome back to Christina's Garage at Gearhead in Training. I have traveled out to Prescott, not Prescott, Prescott, Arizona, to meet with Centerforce, the performance clutch. Let's head on inside. I am at Centerforce, the performance clutch, with Trent. We met at PRI and I was super interested in what you guys were doing. I'm here now. I'm really, really excited to be able to learn a little bit more about clutches and how they work.
All right, well, thank you for coming. I mean, I know it was a bit of a trek for you, so we're here in Prescott, Arizona. It's a little colder than probably you're used to, or certainly I am, because I technically live down in the valley, but yeah, thanks for coming out. So to just kind of kick things off, I mean, I'm assuming you just kind of want to do a little tour of how stuff's made and everything?
Yeah, that would be really awesome.
Okay, well, so this is actually our R&D area. This is where we do our check fits and stuff on whatever new products we have. Sometimes we go back and we'll do some tweaks and improve some existing products and stuff, and that's where all this happens. So not a whole lot going on here today, but as we'll talk to Casey in a little while, and he'll be able to show you, how we're able to design things in CAD. We can actually shoot it directly to the machines. The machines machine out the parts, and then we've got finished goods ready to install, ready to try install. And if all's good, then we put it on the shelf and ship it. So.
Awesome. I'm excited. Let's go check it out.
Hi, I'm Casey Polk, engineering director here at Centerforce. Been here a long time, since high school actually, and had a lot of fun at kind of showing what we do for the design work. So my job's cool because I get to do something different almost every day, and I really enjoy that. But this one here is an example. One of our employees had found this in the archives somewhere, and it's a drawing that I did back in 1987, I believe.
Oh, you actually did it.
Yes.
I didn't realize that. Is really cool.
This old hand drawing with pencil and ruler and compass and that kind of stuff. So we went from paper and pencil to electronic 2D drawings, and so everything was designed and drawn and dimensioned in a 2D program. And then from there, we've transitioned to SolidWorks, where it's all 3D. I can actually take a look at the part moving around. So this is an early model Chevrolet 168 tooth flywheel that would go in a car like yours.
Wow.
The neat thing with this is we can cut it in half. I can look at the cross section on it real easily, see what it looks like for strength and for weight. And then we can also assemble it. We can put actually all the components together before it's even made. I can tell you how much, we can change the material from aluminum to steel, and we can determine how much it weighs even before the part's made, again, from there. And then this program, we also can do the same thing we did over here with the drawing. It's a little cleaner, a little better setup for the shop drawing. So in other words, once the part's designed, then it goes back to get the programming done for the CNCs, which I believe you've seen back there with where the flywheels are being made. But the shop needs the drawings, dimensions to check as the part's made to make sure that it fits tolerances in the right dimensions. So on top of that, we can do assemblies. So here's an entire clutch assembly where we can add the springs, we put the friction material in place, we can explode it, bring it out. Again, we can check fitment before it's even made. Stuff we couldn't do here, or if we made a mistake with a paper and pencil and erase it, start all over, wad it up, throw it away, start all over. Whereas this is so much more flexible. I can add and subtract weight. I can do for more or less strength, more or less weight, that kind of stuff, and design it all right here. So that's a lot of fun. Like I say, it's something different, and we can put all these components all in one piece and basically do some testing before it is even manufactured. So.
And if someone's interested in doing this kind of thing, like if they don't have experience doing, do you need automotive experience to do this type of work? Because there's a lot of engineering, it seems like, that goes into it.
It certainly helps, but you can, as long as you're given a part or a part to work off of, either reverse engineering or working on a component, they could draw it up. As long as you understand SolidWorks, you don't necessarily have to have the mechanical or the automotive background, but it really does help, for sure, yeah.
That's really cool. Oh, I'm excited to see what these
Yeah,
all look like
yeah.
in like physical, like
Right.
see all the parts. That's really
Yeah,
neat.
that's what's neat to start off here, and then for me, I go walk back there once it's completed and the finished part comes off, and it looks like what we just made here. So the only bad side is if I make a mistake here, they can follow all the way through. That's why we have our checks and balances, you know, for the components before they get sent on. I want to make sure that they're right on. And sometimes we'll design a part and like, this looks pretty cool, and we'll go back to actually put it together or have it machined, and then we determine, well, it's a great design, but we can't actually machine it that way. And then we got to come back and change things up a little bit. But we do it all right in-house. So when we say made in USA, made in USA, right here,
Made here.
start to finish. Here's the hydraulic bearing itself, and if you can feel it, it's under temperature. We run about 200 degrees, and that's why the cover was on it, to hold the heat in a little bit, simulate like it's in a bell housing. So we'll run almost 20,000 cycles a day with this just running all day long under temperature. So we're testing the hydraulics, the clutch fingers, the release mechanism, so you can actually see how the disc is, we're creating the air gap with the pressure plate lifts. So every time you push the clutch pedal in, this is what happens in the bell housing, right?
Wow.
You're operating the hydraulics, it releases the pressure, the spring pressure on the fingers, and then creates that air gap and disconnects the engine from the drive line. So that's actually what's going on inside. So we'll do this. We'll run it 250,000 cycles and then take it apart, look at everything, and then run it some more.
And this is when you're designing new clutches or making tweaks that you do this to test it before going into production?
A lot of times, yes, right, yeah. Or we'll pick specific components, whether it's the hydraulic mechanism, the pressure plate, the disc assembly, the spring assembly that's in there. You know, you can see the little wave. I know you saw in the disc department earlier how the spring, that we set the wave spring in there. So we can actually test that here, and we do it under temperature, so we can do it under heat. So it's a pretty good test. So again, we design stuff on paper or on the computer and feel pretty good about it, and then we'll bench test it, and then we'll real world test it, like in the Camaro and other customers' vehicles and whatnot. So we really want to look at it and approach it from a bunch of different angles, because sometimes what works on paper doesn't work on the bench, or works on the bench doesn't work really well like we think it will in the car. So there's a lot of testing that goes involved with that. So this also does friction materials. We can test friction materials on here, and some of the other strength properties as well. So we spend a lot of time doing that, but again, it's kind of fun because it's something different every day. You say, well, how are we going to do this? Oh, we have this equipment, let's try it out. So
I love that. Yeah. Thank you so much,
Yeah.
Casey. I really appreciate you showing me around, and
thanks for coming.
I'm excited to see how all the components come together to make this.
Awesome.
All right, well, to kick things off, I figured we'd show you how flywheels are made. So we make virtually all of our flywheels in-house. We have a variety of different ones. We have billet steel, aluminum, and then we also have high inertia wheels as well. Those are really good for off-road applications. So, but they're all done here in-house. So they actually all start as these raw billets. So they come in as just solid billet chunks, and then they get machined right over here, and then the finished product looks just like this. So there's obviously a lot of magic that happens in between, but as you can see here, we make a lot of different flywheels for a lot of different applications. And like I said, the differences between, say, aluminum and steel is just, it depends a lot. The steel is more for everyday use or, you know, street performance. You know, probably like your Camaro would, ideally you'd put a steel flywheel in it. An aluminum flywheel would be a lightweight application, and that would be more racing oriented. And I'll show you one of the aluminum wheels in a little bit.
Okay.
But to get from that to that requires these machines right over here, which I'll show you now. It's one of several CNC machines that we have. As you can see, we're midway through machining one of our flywheels. This is actually one of our newer part numbers. I believe it's for a Mustang, if I'm not mistaken. So as you can see, the raw chunks come in and they gradually get machined down through a series of steps. And sometimes those steps can happen on one machine. A lot of times it involves several machines. So it'll move from one station to the next, just depending on what they're running and what's required.
Do you always go from the billet to this process? I know some other, there's processes like forging or other things.
That's a great question. So we also sell like nodular iron flywheels, which are basically like stock replacements. Those require like a forge and stuff like that, and that we don't really get into those. We actually source those from one of our vendors. But all the billet steel stuff, such as what you see here, These all start as solid billets because among the things that these are SFI certified, which means that there's an independent safety sanctioning body essentially that sets safety standards for certain parts, flywheels being one of them. And so that SFI certification is basically a certification that guarantees that you as a racer can be reasonably sure that this flywheel is not going to come apart. And actually, a lot of racing sanctioning bodies require SFI certification. So billet steel is one of the requirements for SFI certification.
Wow, that's really cool.
So I'll show you some more finished flywheels here in just a minute, but I would walk to our next station, which is actually our disc department. This is Lupe. She is in the process of building the clutch disc, essentially. So I'll show you where the facings are. But right now, what she's doing is putting Marcel into the disc, and I'll show you what Marcel is. I should have grabbed one here. You'll notice on a lot of clutch discs that they're not completely flat or not completely solid. You can actually squeeze on them a little bit. Okay, you see how it's. I mean, this is not a great example, but you can see that the two pieces are kind of squeezing together and getting closer together.
Okay.
Okay, that is called Marcel, and Marcel is one of the many factors that will show or will affect how smoothly or how quickly a clutch engages. And so basically that squish almost acts like a shock absorber of sorts, where it allows the clutch to start grabbing, but it's not completely grabbed, so it's not like an on-off switch. So that's one of several things that we're doing. So that's what she's doing right now, is putting Marcel into the disc, and then the facings get riveted on later, and we'll show you those now.
What exactly is she doing with the? She's creating pressure.
Basically she's putting bends in them. You know, and those bends. Yeah, see.
This is the way they come. They need flat.
Oh, in this case, she's actually flattening it out.
Oh, okay.
So sometimes we're removing Marcel, and other times she's actually putting it in, putting more in. It just depends on the
Marcel
application.
is that
Squish, and
Wow.
it's caused by the how these aren't perfectly flat. They've actually got a little bit of a bend to them.
and that creates the Marcel.
Yep. Okay, so what Lupe is doing now is putting the clutch faces together on the hubs. So basically, they're riveted in place. So that it's got a safety on there. You don't want your fingers anywhere near that, but it's literally riveting the clutch face to the center hub.
Do you want to get a close up? That is good to me.
What's even neater is that the rivets have little CFs in them.
When you see the end product, you don't think that this is what happens.
Yeah.
It's amazing to me.
So that particular one is a dual friction. So the face that she just did is a dual friction. You notice it's got these segmented pucks. It's not just a full face.
This part, you mean?
That's correct. Yeah. So this is actually the friction surface itself that will engage the pressure plate and the flywheel. And then she's now doing the other side, and that is complete dual friction. However, the difference between a dual friction and a Centerforce 2. Centerforce 2 is a different clutch line for us. That has a full face disc on both sides instead of being segmented on one and the other.
And you showed one of those to me at PRI.
Yeah, so the dual friction is a little bit more performance oriented. It's slightly more aggressive than a factory replacement clutch, but it has more holding capacity. So it's better suited for performance applications.
That is so cool.
And there you go. That's a complete disc.
You wouldn't even realize that the part with you said Marcel?
Yep.
You wouldn't even know that was in there.
Yep. No, but and this one, again, this one doesn't have a lot in it, but there are other ones that are very squishy. And it really just depends on the application. So we actually custom tailor these discs for the specific application so that you've got a good balance between good pedal feel and holding capacity.
Wow.
So yeah, thank you, Lupe.
Thank you so much.
Well, as you saw a moment ago, this is a finished clutch face before it gets attached to the hub. But we actually build all this stuff in-house. Again, this is another example of a dual friction because it's got these segmented pucks on it as opposed to a full face disc, which would have solid friction material all the way around it. And these are actually built right over here. All right, so what these guys are doing here is building the clutch facings. So we have here is our friction material. We actually get these, it comes in basically sheets essentially, and then we have a die cutter that will come in and cut out the different shapes and stuff that we need. So what he's doing right now, believe it or not, this yellow stuff here, this yellow tape looking stuff, is actually the adhesive that will actually bond the friction material to the steel.
And that's what's behind us?
Yes,
or?
That's what this is here. This, believe it or not, that is glue. It
Wow.
doesn't feel like it, it's not sticky or anything like that, but that is actually the glue. So once he's placed, and as you can see here, this is all placed by hand. Once all the different segments and stuff are placed where they're supposed to be, they get put in these ovens right over here. And the ovens, they bake at about, I believe it's about 350, 375 degrees, and they're actually under pressure. So that heat and that pressure will bond the friction material to the facing itself.
Is the heat hotter than what it would get in when you physically use it?
Not necessarily. You can see higher temperatures, but that's just what it takes for the glue to kind of set, essentially.
And after it's set, it's
there. It's not coming off.
That's really cool. And I'm noticing there's a lot of, you have the CNC machines, but you have a lot of hand done process.
Yes. So that's one of the things that sets Centerforce apart, is that because everything is done by hand, we have a greater degree of quality control. After all this stuff is built, there are several checks that everything goes through at every step of the way before it ever gets put into a box. So there'll, on the one hand, people might think, well, wait a minute, mass production, offers like repeatability. But actually with this, we're able to tweak our products to suit individual applications and things like that, but still maintain that quality control level because of all the R&D checks that happen in the process.
Wow.
Another CNC area that we have, and there's several different things that happens here. Sometimes there are some special processes to finish up a flywheel or something like that. That'll happen here. But more often, this is where we do all of the tweaks and stuff that we do for our pressure plates. Now, we haven't talked much about pressure plates, but this is an example of a pressure plate. So this is basically the spring that engages and holds the clutch, once it's engaged. So basically, there's a lot going on in here, more than what you might think, and a lot of it you can't really see. So this is obviously you can see the exterior hat, but these fingers right here are actually part of it's a diaphragm, and that diaphragm is actually the spring. So that diaphragm will push on this pressure ring. So this pressure ring is what the clutch disc actually rides against. So those pucks that we were seeing just a little while ago, those pucks are going to ride on this surface here.
Okay.
And between this surface and then the flywheel. Okay. So.
And what puts pressure on? Like, does anything sit against this?
Yes. So when it's installed in the car, there will be a throwout bearing that's right here. Okay, and it's basically a bearing that is attached to, in most cases, a clutch fork. All right, and that clutch fork is then either hydraulically or mechanically connected to the clutch pedal that's in the car. So when you physically push down on the clutch, what you're doing is there's either mechanical or hydraulic linkage that'll eventually get to the throwout bearing that's riding here, and that will physically push on these fingers and release the clutch, release the pressure that the pressure ring has on the disc, and allows the disc to rotate at a different speed than the engine.
It's a transfer of pressure from the fork to the diaphragm.
Yes.
To, what did you call this again?
Pressure plate is bolted to a flywheel, the flywheels that we saw earlier.
Okay.
So the flywheel and the pressure plate are turning the same speed because this is physically bolted to the flywheel is physically bolted to the crankshaft.
So this whole thing turns?
It's spinning very fast.
Okay.
Very, very fast.
The piece that's putting pressure on the diaphragm isn't moving?
No, but it has, because it's a bearing, part of it's moving. Part of it's moving at the same speed because it's engaged with this. but the other part of it is fixed. Yeah, it's not moving.
And the main purpose of that bearing is to provide the pressure.
Correct.
Okay.
The pressure to release the clutch. So if you pull up to a stoplight, you want to be able to release the clutch. When you push in on that pedal, the bearing is pushing on these fingers and releasing the tension that this pressure ring has on the disc.
Wow.
And then the disc, of course, is attached to the input shaft of the transmission. So the disc is traveling the same speed as the transmission. So when you release this pressure on the pressure ring, then it allows the disc to slow down or spin at a different rate than the engine. When it's engaged, when there's no pressure on these fingers, that clutch is locked in place. Like it can't move. It's sandwiched between the pressure plate and the flywheel itself.
Wow.
So it's kind of complicated. There's a lot going on. But anyway, there's a lot that we do with these pressure plates to make them our own. And there's a couple of patented things that we do that I'll show you now. Okay, so this is the hat with the pressure ring removed. And as you can see here, you can get a better idea about, or see what the diaphragm looks like that the fingers are attached to. Again, this diaphragm is the spring for the pressure plate itself. So one of the things that we do, and I'll show you right over here, in stock form, this diaphragm rides on these ridges that are on the pressure ring. So this is the pressure ring that I was showing you just a minute ago.
You couldn't even
Sorry.
see that inner part.
Yeah, right.
Okay.
Yeah, you can't. I'm sorry. Yeah.
That's
So that's
okay.
the pressure ring, and this is the back side of it. You can't see this because it's normally locked inside here. So in factory form, that diaphragm will ride on these ridges that are cast into the pressure ring itself. And normally they're just pointed little ridges in factory form. All right. So one of the things that we do, and it's a patented technology, it's exclusive to Centerforce, is we go in and we machine these ridges flat. Why would we do that? Well, because you notice we've also machined these little pockets in here. Well, these pockets will eventually have ball bearings in them. We'll put a ball bearing inside each one of these. So what that does is reduces the amount of friction internally that the clutch, the pressure plate will have. So again, that leads to a smoother engagement. Instead of just being on an iron ring or an iron ridge, the diaphragm is now riding on ball bearings, and it's just a much smoother, more efficient way of doing things. The other thing we can do is, you'll notice here that these pockets aren't exactly centered on those rings, right? They're kind of offset one way or the other. Well, when we go and machine these flat, we can actually move, because this is basically the fulcrum for the diaphragm. It's what the diaphragm pivots on, essentially. So what we can do is we can move that fulcrum around, and that will adjust how quickly or how slowly or how gradual or how firmly the clutch itself will engage. So, and again, that's a patented technology that you'll only see within a Centerforce product.
That is so cool. Like, as you said, I can't see all of this
No.
when it's all together, and you put it on your car. Like, this is really cool. My brain is like, I'm very happy right now. And the thought process to get you to this point, to where you can come up with, as you said, this patented.
There you go.
It's really neat to see how you've gotten to this point, and it makes me also really excited for when I'm ready to have a clutch, because with my back, everybody tells me, well, manual's really difficult because of how you have to maneuver things, and with my low back issues, hearing you talk about how it will be smooth with engagement and easier. You obviously still have to use the manual part, but that makes me really excited because it'll be more doable for me to be able to have on my own car.
So yeah, and to your point, and we really haven't touched on it much, but the whole Centerforce was actually founded around the idea of having a performance clutch, something that had a lot of holding capacity, something that could really stand up to a high performance application without having to ramp up the amount of pedal pressure that engaging and disengaging that clutch requires. So back in the day, there were the dominant performance clutch was a 3-finger style called a Borgen back or a long style clutch. It's basically, instead of this diaphragm style, it was literally like 3 arms that would come out. The problem with that style of pressure plate is that and the only way to increase clamp load and therefore holding capacity is to increase the spring rate internally, which is the direct correlation to how much pedal pressure it takes to engage and disengage the clutch. A diaphragm takes quite a bit, a slightly different approach. It doesn't take near the pedal effort that it does with the other style to engage and disengage the clutch. But by doing tweaks such as this and some other stuff that I'll show you in a little bit, we're able to still increase that holding capacity to performance levels. It still, can hold 1,000, 1,400 horsepower, just depending on the application, but without having a linebacker's left leg to do it.
And I had a hard time learning how to do the clutch in some older vehicles.
Sure.
As I felt like I had to literally go all the way down to the bottom, and I couldn't, so that makes me really excited.
So as I mentioned, primarily what we do here is work on the pressure plates and stuff like that, but there's also, we also will sometimes do the finish machining on some of our Lightened steel flywheels. This is actually a flywheel that you would see with our twin disc systems. So we've shown you all kinds of single disc clutches. There's all kinds of dual disc clutches too that we can talk about in a little while. But I just wanted to show this because they're nice, pretty, and machined. You'll notice here that there's these windows that are machined out of it. Okay, so we've done that so that we can reduce the amount of overall weight that this flywheel has. And not only is how much material is removed is important, it's also important as to where. So you'll notice that all these windows are pretty far to the outside. That's because removing weight out here is going to have a much greater effect on overall inertia than, say, moving material out of here. So it's the same as, imagine, like tying a rock to the end of a string, and if the string's only a couple inches long and you're spinning it, there's not a whole lot of inertia, but you run it 3 or 4 feet out, that's got a lot of inertia. The same principle applies.
Kind of like holding weight, right? If you hold weight further from your body, even though it's the same actual weight, it feels heavier than if you hold it closer to your body.
So yeah. So this is just one example of our flywheels that we would use with our SST, which is a solid street twin, as well as our dyads. And those can get up to 1,400 to 1,600 foot-pounds of holding capacity, depending on, that's a lot.
Wow. And
so, yeah.
This, you had 2 different types of billets. The lighter colored one, that's this?
So I think that's, you think the steel versus aluminum.
Yeah.
So this is still a steel flywheel.
Okay.
We have, I didn't really show you an aluminum flywheel, but I can.
Okay.
We can get to that in a minute. But yeah, this is a billet steel. Okay, so we've machined our pressure ring, we've made our modifications to it, we've reassembled the pressure plate. One of the last steps that we do before we string weights, which I'll discuss in just a minute, is we have to paint the hats, of course, and this is where the signature Centerforce orange comes from, is right here. Believe it or not, it's not terribly sophisticated, it's just a regular old paint booth, but they come in raw here, and then, as you can see here, those are just drying, ready to go, and then we'll go over to the weight station. There are a variety of different patented technologies that go into a Centerforce clutch. Well, this is actually one of them, and it's our most recognizable. And it's the centrifugal weight system. Now, these little weights on here, you're only going to see on a Centerforce clutch. And it's probably, like I said, it's kind of our signature, so to speak. But they're not just pretty or whatever, they actually serve a purpose. So basically, these weights act as a function of RPM. As RPM increases, these weights are going to spread out on the clutch fingers while simultaneously lifting up on them. What does that do? That actually increases holding capacity. So it increases the amount of force that the pressure plate is exerting against the clutch disc. So and it's doing it as a function of RPM. So the higher the RPM, the more power the engine is putting out, the more holding capacity you're going to need. So the advantage to doing it this way is that it's one of the ways we're able to increase holding capacity without increasing pedal effort. So in some cases, these weights can actually be good for up to 10% of the holding capacity of the clutch itself.
Which, especially for me, that's going to be super important with my back.
Absolutely, absolutely. So yeah, so this is the station that they're doing that. There's a variety of different ones that are used depending on the type of pressure plate, but they'll actually get strung onto the fingers, and then there's a wire that'll actually hold the centrifugal weights in place, and then there's this ring here that kind of locks it all together, so to speak. All right, well, we've showed you how discs are made, we've showed you how pressure plates are made, we've shown you how flywheels are made. This is actually where all that comes together in a box. This is our final assembly area. So this is where we do any final QC checks that need to happen, and then of course, package them up and ship them out. In this case, this is actually a complete clutch kit. I believe these are for Tacoma, if I'm not mistaken. But this will include a flywheel, a pressure plate, and a disc all at once. But we also do sell a variety of these components individually. So you can buy just a clutch disc, you can buy just a pressure plate, buy a clutch disc and pressure plate, you can buy just a flywheel. So there's a variety of different ways that you can purchase the product. We try and be as accommodating as we can to everybody.
And if someone is interested in either buying a product from you and not knowing what to get, or maybe they're interested in potentially working for you or doing something, because seeing this whole process and they're interested, how would you suggest they get in touch with you guys, or like where should they start?
So best place to start is our website, which is centerforce.com. That will have all of our products, applications, general product information, and then all the way down to like a year, make, model search, to where you can search for your specific vehicle, and you can see all the different products that we have for your specific vehicle. In terms of, we're always looking for good people. If you're looking to relocate to the mountains of Arizona, but best thing to do is probably give us a call. Once again, phone number's on the website, or just hit us up on social media. We have all the usuals: Facebook, Instagram, YouTube, and that they're all pretty much, the handles are all pretty much Centerforce.
Okay, and I'll make sure to put them in the captions so people can find them. I'm so grateful. Thank you so much for having me here. It makes me even more excited because I will eventually be coming out to do my clutch when I know Sure. what I'm going to do exactly for mine.
Sure.
Just seeing how the process works, it makes me even more excited. I really appreciate being able to be here. Thank you so much, Trent.
Thanks for having us. Thanks for coming. We appreciate it. It's great having you.
Yeah, I'm so excited. Thank you so much. And if you guys are interested in seeing more, I'm going to be sharing more about the different products that they offer next week. And then you'll have to see in the future when I come back to do my clutch.